Hello guys, welcome back to my channel, and in this video we will be looking at Spark accumulators. So what are accumulators? So accumulators are variables in which we can only add values to through any associative or commutative operation. And since we can only add values to, so various tasks can add value to accumulator at the same time, that is in parallel. If you don't know what tasks are, in my previous videos I have already covered what tasks are. Now Spark supports only one type of accumulator, that is numeric accumulator. So there are two numeric accumulators in Spark. One is of type long and another is of type double. And in case if you want to add values of other types, Spark has given you support to add, or basically to have your own type. So there are various few things that are important in terms of understanding accumulators. So the first thing is, if you have defined your accumulator or performed any action on an accumulator in the action, then Spark will guarantee that that action or that update in an accumulator is performed only once. But that is not in the case of transformations. Why? So you know that actions are performed only once, and whenever we have performed any action on any kind of previous transformations, and in the case of you have written accumulator in transformations, so each time an action will be performed, the whole DAG tree gets executed. So in the case of accumulator, if you have written accumulator updates in any transformation, that update will, or that operation will be performed on accumulator multiple times, in this case as many times as the transformations are executed again. Another thing that is important to know is accumulator don't change the lazy evaluation model. What does it means? It means that we know the tag gets executed only when the actions are performed. So in the case where you have written accumulators in any transformations, right, the accumulators will not get executed in the transformations unless and until there is an action on that transformation. So we will cover all these topics in detail. Let's go one by one. So this is a sample program that I have written. Okay, so here I am using sc.parallelize method to basically split it into multiple tasks, that is 10 tasks, and I have used predefined accumulator that is provided by Spark, that is of type long accumulator. There is another accumulator of type double. Okay, and I'm performing one action on this RDD, that is for each, which is adding the value to an accumulator, right? Remember that we already discussed that if the accumulator is written in an action, so the for each is an action, then Spark guarantees that the value that has been added to an accumulator will be, or the operation that is added to the accumulator will be performed only once. Say suppose I am doing any operations on an accumulator in any transformation, that is this data for map. Okay, not for each, I'm doing it in a map, this data dot map. Then this transformation, okay, will be executed for every action. Say after doing a map operation, I'm doing an action that is of collect. I'm making collect operations say 3 or 4 times. Then for each of the actions, right, map will be executed again and again. So in that case, the value will be added to the accumulator again and again whenever that transformation gets executed. So in this case, Spark will not guarantee that the operation or the updates that you are performing on accumulator will be performed only once. Another thing that we discuss is accumulator gets evaluated only in terms of any operations that is performed on a transformation post that we have performed any kind of action. So in this example, we are doing for each. For each is an action. Say for example, we have written an accumulator in a map function, right? Like this data dot map. Then in that case, that accumulator will not be calculated until and unless you have an action on that disk data. Okay. Now let's go to what user-defined accumulators look like. So this is an example of user-defined accumulator. We will actually go into the live code, but of a long accumulator that is provided by Spark itself, not a user-defined accumulator. In case you want me to make a video on user-defined accumulator, just write in the comment section. Okay, so what you need to do for user defined accumulator is you need to implement accumulator v2. Okay, that is an interface, and you need to provide an implementation of some of the methods. Okay, so one of those methods is reset and another of those methods is add. Okay, now let's look forward. Right, like I have already told you, like you have performed any updates on an accumulator in any transformations. In this case, I'm performing, accumulator updates. That is adding the value to an accumulator in the map function. Now, map is a transformation. In this case, I'm not calling any action. So, in this case, the value will not be added to an accumulator, and by default, accumulator value is 0. So, 0 will get printed. Okay, and another thing that is important for you to notice that the accumulator values, whatever you calculate values and add to an accumulator, will only be understood by the driver program. Our tasks or our worker nodes will not be able to fetch the value of an accumulator. It can only add the value to the accumulator. Okay, now let's look at your live example code. Okay, so I have written the same code. Okay, now we will be looking at how Spark Web UI looks like when we have any accumulators variable. Okay, so this is the same code. I have already covered this code in my previous videos. Okay, I have just commented out the codes that are not required and only have the code that is required for the accumulator. Here I am using long accumulator. You have another type of accumulator, that is sc dot say if I do accumulator. So I have long accumulator and I have a double accumulator. Here was a UMULAT. So you can see that I have only a long and a double accumulator. Okay, so I have already compiled the code and I have already packaged the code. Okay, so only thing that you need to do compile when you are using SBT is compile, run the compile program and run the package program. Okay, so that's been done. Okay, let me clear out, refresh. Okay, nothing is there. So let me run this program. Okay, so I'm submitting this program. So this is the same previous program, so I'm not changing any input parameters, but it won't perform any such operations. Okay, let it execute. Okay, so now let's look at the output. Okay, so as you can see that in the code on line number 20 I have done for each. Okay, so this is an action, and on line number 22 collect is an action, right? So I have two actions, that's why I have two jobs. Okay, the thing that is important for us to know accumulator is the first action. Okay, that is for each. So I have altogether 10 tasks. As you can already see in parallelize, I have defined 10 tasks, so I have altogether 10 tasks. Okay, now let's go and let's open it up. Okay, now you can see that I have accumulators, right? And the value of the accumulators is coming up to 171. Okay, and since I have 10 tasks, you can know that what each task has done to the accumulator, right? So let's go to these tasks, right? It's a very simple program, so it will be easy for me to explain you what each task is doing. So in this example, what we're doing to the accumulator in the action is we are adding the value. Okay, we are looping into each variable of the array and we are adding the value to the accumulator. Okay, by default the accumulator value is 0. So you can already okay, so let's have a look. So my 10th task has produced a value of 35, right? So looking at this example, we can know that this task got two input variables, that is 17 and 18. Okay, so we can actually derive the distribution of our this array using the parallelize method, where I have given 10 tasks. So the 10th task is adding a value of 35 to an accumulator, right? So how that 35 comes into, so that task would have got two variable from the array. Similarly goes for 31. 31 is 15 plus 16, 31. There were 27. 27 is 13 plus 14. Okay, and you can see that accumulator fifth, okay, just got, okay, so we have calculated 27. Let's go to 23. So 23 is 11 plus 10. Okay, post that it's 10. So this task got only one variable. Okay, so each task is adding whatever input it has given. Okay, and finally they will be adding to a common variable, that is a long accumulator, okay, where I have given that long accumulator of name my accumulator. That's why it's my accumulator, okay, and the combined value is 171. So all this will add up to 171. And one thing that you need to keep in mind is only driver program can read the value of accumulator, not the worker nodes or the worker task. The only job of the worker task is to add the values to an accumulator. Okay, so that's all for this video on accumulator. If you have any questions, just comment me on the comment section. If you like this video, do subscribe to my channel and press the like button. Bye bye till the next video.